Okay. To derive this first part, we need the product rule. So I'm going to put 2x together and think of that as 2x times y squared. So to derive the first, you get 2 times the second, y squared, plus 2x times the derivative of the second, which is 2y dy dx. That's the derivative of the first part. Plus, I'm going to have to write this like this because we got to do product rule again here. I'm going to put 3x squared together and derive that. That gives me, so I'll put this all in parentheses here. So that's going to give me 6x times y plus 3x squared dy dx. And that is the derivative of the left-hand side, all this stuff together. And that's going to equal tangent xy. When you derive that, you get secant squared of xy times the derivative of the inside, which is going to be, I'm going to run out of room here, so I'll write it underneath, but times the derivative of xy is derive x, you get 1 times y, plus leave x alone, derive y, dy dx. So there we are. So just trying to write this all out together here, a little bit nicer, maybe a little bit smaller. We've got 2y squared plus 4xy dy dx plus 6xy plus 3x squared dy dx, and that equals, now really we got secant squared xy times this sum in these parentheses, so we're going to distribute secant squared to y and to x dy dx, and that's going to give us y times secant squared xy plus x secant squared xy, oh man, I'm going to run out of room here, but times dy dx. So, ooh, that looks ugly. This says secant. Alright. So, that is the derivative. Very hard to fit on this little screen here. It's probably hard to fit in your notebook if you're doing this on paper. But this is about as big as they're going to get, at least in my class, or any of these videos. So, we want to get everything with dy dx on one side, everything without dy dx on the other, and then factor out dy dx. So what that leaves us with should be dy dx times, on the left side, we're going to have 4xy plus 3x squared. That's this guy and this guy. And then we'll subtract off x secant squared xy. So that's all on the left-hand side. And that's going to equal, what's on the right-hand side is y secant squared xy. That's right here, this term. And we need to move over 6xy and 2y squared. Subtract that off. So we're going to get minus 6xy and minus 2y squared. Okay, so barely fitting it in there. And the final answer for this is dy dx is equal to y secant squared of xy minus 6xy minus 2y squared all over, and this is getting a little out of hands. This is gigantic. You'll probably never see this anywhere, like besides in an implicit differentiation section, but that's okay. So 4xy plus 3x squared minus x secant squared xy, and that is the derivative. And even though this is super scary looking, all this really represents is, if you want to know the slope of the curve, the instantaneous rate of change of y with respect to x of this curve, that's the slope really, then we get this thing. And you can plug x and y into there and get a number back out, and that was what the slope would be.